Hey guys, video 21 now. This is over 8.6. There's a couple new things that we're going to do, but backed up by a lot of old things that we did, so I'm going to talk about some of that. The beginning of this video is going to be a lot of detail of stuff that I want to make sure I get through before just doing some problems with you later. If I do what I'm going to do with number 2 on this reteach for all of them, this video could get really, really long. So I want to try to see if I can do this without making it so that we have to do every one the extremely long way. Let's see how it goes. Scale factor is something that you should have, you should hopefully remember. All of chapter 6 and 7 had scale factor and similar figures in it. Okay, here it's how much larger or smaller one solid is than another. You find figure B in this section given a figure A, their surface area. Okay. We learned about similarity, like I said in 6 and 7. We just learned about surface area over the course of the last couple sections. So now we're going to use both of those things to put together to do this new section. This is surface area, and we're going to start using SA for surface area to save us some writing. Of B, the second figure, in other words. Surface area, again, SA that we're going to stop using, of A, times the scale factor. The thing I forget a lot, and what I hope you don't forget, is that this has got to be squared. Your scale factor has to be squared before you're going to find your new surface area. Okay? So if I look at 8.6 reteach number 2, surface area of a pyramid they give us is 38 feet squared. And I'm going to stop there for just a second to explain something, because I know some of you learners might be ones that need to see where that 38 might come from. And this is supposed to be a pyramid. And I didn't have a great example around the house of a pyramid, so I went on YouTube and I constructed one out of paper. It was pretty amazing that I've never done this before, because normally I'm at school and we have some shapes or something that I can show you. So this one I constructed out of paper. This is a pyramid. This happens to be a square pyramid. There's a couple different types of pyramid. This one's a square pyramid because the bottom is the shape of a square. Okay. There are triangular pyramids also where the bottom would be the shape of a triangle. But I thought maybe, just maybe, this would be a little bit more clear if you knew the bottom was a square and then you had triangles around it. So if the surface area of this pyramid is 38, that might mean that you had a square pyramid, I drew it over here as well, that had a bottom of 4, if you can see my little 4 there, okay, which means my whole square on the bottom would be 4s. And the area of a square is one of the easiest ones you guys have ever learned. 4 times 4 is 16. The area of that bottom would be 16. And if I had that, and maybe I gave you a height of this triangle as 2.75, if I found the area of the square, and there's 4 triangles around a square pyramid, if they were each heights of 2.75, bases of 4, each of their areas would be 5.5, if I remember correctly. Yep. Each triangle would have an area of 5.5. Okay. The triangle height would be 2.75. The triangle base would be 4. The square base of the pyramid would have an area of 16. That 38 comes from a pyramid that would look like this with those dimensions. Okay. I'm not going to do that for everyone. That took a long time to kind of explain. But just in case you want to know where the first figure comes from, it's taken from a figure that they had, that they figured out that surface area by doing those things. Okay, that's a mouthful, but hopefully when I just explain these as we go forward, you'll catch on pretty quick. So again, they said the surface area of this pyramid is 38. Now remember, scale factor we take and we square it. They gave us a square factor of 1/3. Well, when you square 1/3, you get 1/9. So actually what we're doing is 38 times 1/9, which in other words really just means 38 divided by 9. And when you do 38 divided by 9 in your calculator, you get 4.2 feet. And you will see that exact same answer on your answer sheets. These should all be very close to the exact same answer. Just remember that we're rounding off to the nearest tenth on most of these. So if you see 2, 3, or more digits afterwards, we're only going to the tenths place. Okay. I went ahead and put the next problem from the next page. This was the reteach page. The next problem I'm going to do is from skills practice, and it's going to be problem number 2. Number one I did for you when I made the answer key, homework and answer key for you for this week's assignment. But they say this is a triangular prism. Okay, triangular prisms, harder to come up with an example. I could have maybe come up with a folded piece of paper also, but again, I wanted to speed things up. I thought maybe think about a pickle spear. And if you know about those long pickle spears, they're kind of triangular shaped and long. That would be more like what a triangular prism would look like. And they say the surface area is 60, and they give us a scale factor of 1/5. Well, we have to square the scale factor. We can't forget to do that. So this is really like 60 times 1/25, right? In other words, it's 60 divided by 25, and when you take 60 and you divide it by 25, you punch that into your calculator, and it rounds to 2.4 centimeters squared. Okay, these are all squared dimensions. Okay, that's kind of important for one of the harder ones on these pages, which I think is going to be the very next one I do is one of the hardest ones on these pages. Yep, I'm going to skip to number 8 on the skills practice. So you can stop the video, catch up on those, but once we got going on those, I think it's kind of straightforward as far as just take the surface area of 1 and you multiply it by the square of the scale factor. Okay. Number 8 though, nice hard one. It has this rectangular prism. Okay, in other words, it's got a box. And I'm going to right away piece apart the box and say, okay, the box has a top of it, and it's the same as what the bottom of it would be. It has 2 sides. That would be these. And then it has a front and a back that maybe I can kind of put back there. There's 6 sides to a box, remember? The 2 sides, the top and bottom, and the front side and the back side. Now if you take the time to find all of these, based on the dimensions that they give, this box over here would be 80 for the area of that rectangle. And since there's 2 of those, this would also be 80 here. The top and the bottom of the box, if you did 24 times 10, that would mean the top was 240. Actually, not the top. It's going to be these guys. This one's 240, and this one's 240. Okay? And then the top and bottom are actually going to be 192. And all I did there, guys, is take the area of all the rectangles around a box. Okay, when you add those guys up, you get 1,024. Okay, all of that adds up to 1,024. So if we have this, that's 1,024, and they give us the scale factor of 10 there. That means we've got to do 10 squared though, which that means that's 1,024 times 100. Okay, and that means we're going to get that 1,024 and tack 2 more zeros onto it so that we get 102,400, and that's centimeters squared. Okay, if I piece this box back together for the volume part of it, boxes kind of look like that, and they give us a dimension of 24 down here, and a 8 here, and a 10 here. Volumes of boxes are simple, and I'll write it just real quick. That's just length times width times height, isn't it? Those ones are all pretty simple, which means if I do length times width times height, when I multiply all those together, 24 times 8 times 10, that gives me 1,920. Okay, if I get that for the volume of this original box and the scale factor is 10, be careful because we haven't talked about volume on these much, but volume is a cubed measurement, which actually just means that it's a three-dimensional shape that you're finding out what's taking up that space, right? A box is three-dimensional. And so if it's three-dimensional, we're not just going to square this scale factor, we're actually going to cube it, okay? So that means if we have this 1920, and we're going to have a scale factor of 10, we're actually going to be 10 times 10 cubed, because this is volume, not surface area. Not always the most convenient thing for them to throw a volume problem at you while we're learning surface area, but they do just because they're so kind. That means I have 1920 with 3 more zeros. 1, 2, 3, which means I'm going to have 1,920,000, and that's centimeters. And this is again why we multiplied by 10 cubed, is because this is centimeters cubed for volume. Okay, so you need this guy for your surface area, and you're going to need this guy for your volume. Okay, that's definitely the hardest one out of the ones I'm doing for you. Number 9 on that same page is very similar, but I think it's written so that it's a little bit easier for you on that one. Okay, I'm going to skip to the homework page. Make sure you catch up on this. This is a lot of writing, so you might have to pause the video for this to make sure you're with me. Make sure you understand where the numbers come from. Hopefully I explained it enough so that if you have to play the video a couple times, you might have to do so. But let's look at the homework practice. First couple are going to be very basic. Okay, like I'm going to look at number 1. If it has a surface area of a cube, okay, the cube, you guys kind of know what a cube looks like, I hope. Okay, it's a box basically, and it says that surface area equals 400. Okay, and then it gives us a scale factor of 3. So we just take 400 times 3 squared, which is really 400 times 3 squared is 9. And when you do that, you simply get 3,600, and that's millimeters squared. Yes, that's my dog. If I jump down to number 4, talking about a wedge of cheese. Okay, wedge of cheese. They don't really concentrate on how you find that area. We've never used really a wedge formula. Kind of like a conish type shape. But if you have a wedge of cheese that's a 215 surface area, and they give you the scale factor of 1/2, remember we have to take that scale factor and square it. So that means it's 215 times, actually what would be 1/4, and 215 divided by 4 would give you your 53.8, and that's centimeters squared. Okay, so those first two are a piece of cake, and so are most of the problems on this page. I did jump down for you and do one of the hardest ones on this page. I'm jumping down to do number 7. Number 7, when I first looked at it, it looked like it might be fairly difficult too, but it's really not. If you remember what we just did on number 8 on the skills practice page about volume as a cube measurement, remember that? So let's think about this. If they tell us a cylinder, which I even have a visual aid for a cylinder. Remember, a cylinder looks like this. Okay, visual aid in a cylinder, that surface area, actually we're talking about volume, and I mentioned that, sorry. Volume of this guy is now 2240. So that means we had a cylinder. It was a really rough cylinder. And this had a volume that we are trying to figure out. We have a bigger cylinder, and now this volume is the 2,220 2,240 that we mentioned. Okay, that was a scale factor of 4. Remember, if it's volume, the scale factor must be something that's cubed, right? So we have to take that 4, and we're going to cube it. And 4 cubed is 64. Okay, I already had a lot of thoughts thrown at you here. We don't know the volume of the first cylinder. We're given the second one this time, and we got to go back and find the first one. So if we're given the volume of the second one, we got to now think, okay, this was enlarged by a scale factor of 4, but it's volume. Volume is not that formula. Volume has to be something cubed. So if it was cubed, it was 64. 4 cubed is 64. So that means with this first shape, we would have had to have 2,240, and we'd have to divide by 64 now to find that. And this volume here must have been 35, and we don't get a specific unit, so we just say units cubed. Okay, this volume here would be 35 cubed units cubed. Okay, that's all I'm going to do with you today. I've already made the homework assignment for you, so check that out on Google Classroom. And that's video 21 for you guys.